Okay, hi everyone. My name is Li Qi and here's my teammate Chen Xu. The name of our project is Predict Survival on the Titanic. So as we all know, the sinking of the Titanic is one of the most infamous shipwrecks in history. That tragedy killed over 1,500 passengers and crew. This sensational tragedy shocked the international community and led to better safety regulations for ships. Although there was some element of luck involved in surviving the sinking, some groups of people were more likely to survive than others, such as women, children, and the upper class passengers. So our project focused on building a model to predict what sorts of people are likely to survive and comparing results with the real situation. There are three parts of our project. The first part is data handling, including importing data with pandas, cleaning unnecessary data, and exploring data through visualizations with matplotlib. The second part is data analysis. Here we use machine learning techniques such as logic regression model and support vector machine. The third part is valuation of the analysis. We use key-false cross-validation to value results locally. About the future challenge, I will explain later. Okay, here's the first part, data handling. And as you can see, the summary holds quite a bit of information. First, it lets us know we have 891 passengers to analyze here. Next, it shows us all of the columns in data frame. Each column tells us something about each of our observations, like their name, sex, or age. These columns are called a feature of our dataset. And here the SIBSP means siblings on board. Here part means parents on board. And the NAN means missing values. As you can see, the features ticket and cabin have many missing values, so they can't add much value to our analysis. To handle this, we will drop them from data frame to preserve the integrity of our dataset. So here is the code of cleaning data. And here is part of the code that exploring our data with visualizations. And here is the result. The first picture is a bar graph of those who survived and those who did not. 1 here represents those who survived and 0 represents dead. And then let's break the previous graph down by gender so we get these two graphs. This is the blue represents for male and the pink represents for female. So it's clear that although more men died and survived in raw value counts, females had a greater survival rate proportionally than men. And we add class to our graph, we get these four graphs: female high class, female low class, male low class, male high class. So this is our data handling. The next part is data analysis. Here we will use logistic regression. In statistics, logistic regression is a type of regression analysis used for predicting the outcome of the categorical dependent variable based on one or more predictor variables. So let's look at the picture here. The blue dot means the calculated probabilities of survival. So although we get these blue dots, we still need to translate these probabilities into a binary decision we are looking for. We could say that our survival cutoff is anyone with a probability of survival over 50%. In fact, this tactic would actually perform pretty well for our data and will allow us to make decently accurate precisions. So the right line here is the 50% cutoff. The right line here. But clearly we need a more exact way to make that cutoff. So here we need to build a model with logistic regression. Here is the first step. We define formula for the model. Here is the formula. Survived equals to P class, add sex, add age, add siblings, add embarked. The second step is create a regression-friendly data frame that sets up Boolean values for the categorical variables. Here is the result. And the third, which is also the final step, is graphically compare the prediction of our model to the actual values. So this is our final results. The blue dot here still represents the calculated probabilities of survival, but here we have red dots. Red dots are the results of our model, and it's binary, means it's either 1 or a 0, which also means either survived or died. So this is how our model works. Step 1, we read the dataset. Step 2, we examine our data frame. Step 3, we add our independent variables to the model. Step 4, we get the final result. So our model works fine here, but furthermore, what if a more complex decision boundary, like a wave, a circle, would describe the variance better than a line? Here we need to use support vector machine. And here's the part of the code here. And then we get, after we add the SVM to our model, here is our result. Any value in the blue means survive, while any one in the red did not. So let's check out the graph for the linear transformation. It created its decision boundary right on 50%. That guess from earlier turned out to be pretty good, as you can see. The remaining decision boundaries are much more complex than our original linear decision boundaries. These more complex boundaries may be able to capture more structure in the dataset. Here is our future challenge. The first one is if the line or the boundary doesn't work, so we should use random forest. The second is we should increase our accuracy. The accuracy right now is about 85%. So thank you, and let me show you the code. The first part is data processing. Data pre-processing is here, and after we run these codes, we will get several graphs like this. Distribution of survival by age, class distribution, age distribution with class, passengers per boarding location. This is the first part of our code. The second part is data visualization. It's here, and after we run this, we will get several graphics like this. This is survived or died. This is survived or died with gender. This is survived or died with gender and class. The third part is modeling. So this is how our model works basically. Here is our code, and we get the result here. As I'm expanding the slide, you can know what it means. Okay, then we add SVM to our model. Here is the SVM code. After we run this, we will get a picture like this. I have also explained it earlier. So that's all. That's our final project. Thank you.